You open a file and forget to close it. You acquire a lock and forget to release it. Your database connection leaks, and your test suite hangs forever. I am Ahas. Today in episode 26, Context Managers, you will learn how Python guarantees cleanup, no matter what happens inside your code. We will cover the with statement and what really happens with dunder enter and dunder exit, writing your own class-based context manager, the contextlib.contextmanager decorator for turning one generator function into a full context manager, exception handling inside dunder exit, including how to deliberately suppress an error, using multiple and nested with statements, and real production patterns like timing a block and temporarily changing state. By the end, you will build a transaction context manager that commits on success and rolls back on failure. Let's go. The with statement guarantees cleanup, even if an exception happens inside the block. Look at the code. On the left, the manual way. We open a file, read from it inside a try block, and close it inside finally for extra lines, and if you forget the finally block, the file leaks. On the right, the same thing with open as f. Python calls dunder enter on the file object and binds its return value to f. The block runs. Then, no matter what, even if the block raises, Python calls dunder exit, which closes the file. With replaces try plus finally for any object that defines dunder enter and dunder exit. That is the entire context manager contract in two methods. You can make any class work with the with statement by defining two methods, dunder enter and dunder exit. Look at the code. We define a timer class. Dunder enter runs first. It records the start time using time.perf_counter and returns self. Whatever dunder enter returns gets bound to the as variable, here t. The code inside the with block runs next, some heavy calculation. Then dunder exit runs. Python always calls it, passing exception type, value, and trace back if something went wrong, or three knowns if everything succeeded. Here it calculates the elapsed time and prints it. With timer as t gives you the timer instance as t inside the block and guarantees dunder exit fires on the way out, success or failure. Writing a whole class for a simple context manager is overkill. contextlib.contextmanager lets you do it with one generator function. Look at the code. On the left, the class-based timer from before, two methods, 8 lines. On the right, the same thing with the context manager decorator. Everything before yield acts as dunder enter. That's your setup code. The value passed to yield becomes the as target. Everything after yield, inside a finally block, acts as dunder exit. Your cleanup code, guaranteed to run even if the with block raises because it's wrapped in try finally. One function, one decorator. At contextlib.contextmanager gives you a fully working context manager. Dunder exit receives 3 arguments whenever the with block raises: exception type, exception value, and traceback. All 3 are none if nothing went wrong. Look at the code. Our suppressor class stores a tuple of exception types. Dunder exit checks if exe_type is one of them. If it matches, it prints which exception was suppressed and returns true. Returning true tells Python, I handled this, do not propagate it. The with block exits as if nothing happened. If it doesn't match, dunder exit returns false, and Python re-raises the exception normally after cleanup finishes. Here, with suppressor, a value error catches the value error, prints it, and the program keeps running. Be careful, though, silently swallowing exceptions can hide real bugs, so only suppress what you explicitly expect. You are not limited to one context manager per with statement. Look at the code. With openOf.txt as src, openOf.out.txt as dst. Both files open together and both close together in reverse order. dst closes first, then src. Since Python 3.10, you can also wrap multiple context managers in parentheses across several lines for readability. Same behavior, easier to read. And you can nest with statements. An inner with block runs entirely inside an outer one. Dunder exit calls fire from the inside out, just like unwinding a stack. Whichever style you use, one line, parentheses, or nested, the cleanup order is always the same. Last entered, first exited. Let's look at 3 production patterns built on context managers. First, timing any block of code. A timer context manager records the start time in dunder enter or before yield and prints the elapsed time in dunder exit or after yield. Second, temporarily changing global state and guaranteeing it's restored. For example, changing the working directory, then restoring the original directory in a finally block, even if the code inside raises. Third, thread synchronization. Threading.lock is itself a context manager, with lock acquires it on enter and releases it on exit, so you never forget to unlock, even during an exception. All 3 patterns share the same shape: setup or save state on enter, restore or release on exit, guaranteed. ContextLib ships with several tools that solve common cleanup problems instantly. Let's cover the 4 most useful ones. First, a contextlib.contextmanager turns a generator function into a context manager, as we just saw. Second, contextlib.suppress. With contextlib.suppress, a file not found error silently ignores that one exception inside the block, replacing a try except pass. Third, contextlib.redirect_stout temporarily sends print output to a file or string buffer, perfect for capturing output in tests. Fourth, contextlib.ExitStack dynamically manages any number of context managers, all guaranteed to close in reverse order, even when you don't know how many you'll need until runtime. These 4 tools cover almost every cleanup pattern you'll ever write. Our mini project, a transaction context manager that commits on success and rolls back on failure. This is the exact pattern behind every database libraries with connection.begin. Look at the code. We define a transaction class wrapping a database connection. Dunder enter prints begin and returns the underlying connection. Dunder exit checks exe_type. If it's none, meaning no exception occurred, it commits and prints commit. If an exception occurred, it rolls back instead and prints rollback, then returns false, so the exception still propagates to the caller. Inside the with block, we run 2 update statements. If both succeed, we commit. If either raises, dunder exit rolls back first, then lets the error continue. This commit or rollback shape is exactly how database transactions, batch writes, and multi-step operations protect themselves from partial failures. Your challenge: build your own context managers from scratch. Step 1. Write a class-based context manager called suppressor that takes any number of exception types, and in dunder exit, returns true only if exe_type matches one of them. Otherwise returns false. Step 2. Rewrite suppressor using a contextlib.contextmanager with a try except block instead of a class. Step 3. Write a timer context manager that prints elapsed time on exit and use it to time a loop that sums 1 million numbers. Step 4. Use contextlib.ExitStack to open 3 files from a list of file names, all managed dynamically, and confirm all 3 are open. Step 5. Combine your timer and suppressor in a single with statement using parentheses, deliberately trigger an exception, and confirm both still clean up correctly. Paste your context managers and their output in the comments. I read every single one. Let's recap what you learned today. The with statement guarantees dunder exit runs, even if the block raises. That's the entire context manager contract. Dunder enter sets up a resource and returns the value bound to as. Dunder exit cleans up, receives exception info, and can suppress an exception by returning true. At contextlib.contextmanager turns a single generator function, split by yield, into a full context manager. Multiple and nested with statements close in reverse order, like unwinding a stack. Contextlib.suppress, redirect_stout, and ExitStack solve common cleanup problems in a single line. The mini project build a transaction context manager that commits on success and rolls back on failure. Next episode, generators and iterators, yield, the iterator protocol, generator expressions, and iter tools. Subscribe so you don't miss it. See you tomorrow. Context managers, mastered. Your resources now clean up automatically every single time. No leaks, no forgotten close calls. Subscribe for the next episode. Drop your own context manager in the comments. I am Ahaz. See you in episode 27.